In this video, I'd like to go over Newton Laws 2, the UT Quest assignment. Looks like this. Keep in mind that each person's assignment has different values, different results, but the questions are pretty much the same. So I'm not going to necessarily go through each and every one of these, but I want to go through the couple that gave everybody the most difficulty. And I highly recommend that you work back through these on your own on paper. Even though you may not get credit back on the UT Quest, we will continue to get work in these types of problems, and there's no reason to move forward when you can't get the previous problems. So what I'm going to begin with is really this first question here, the conceptual question 4. So for my printout, it would look like this on number 4, where you have 4 forces, one up, one down, one to the right, one to the left, and you're simply comparing them, right? So that goes back to the very basics of how we started this whole thing. Remember broom ball and all the forces that we drew. So opening up my whiteboard, right? If we have these 4 forces, actually, I guess I could work through it right on that sheet. If we have these 4 forces, I'm not sure if it'll let me draw on that. Nope, I don't think I can. Okay, so we'll go back to this, right? So our 4 forces are simply F1, F2, F3, and F4, right? So the first question asks, if the object is accelerating, your net acceleration is to the right. So in order for that to happen, remember, you have to have a summation of forces. The balance of the forces must be to the right. The summation of forces in the y, and so on. So this goes back to the very basics. This is what would have to, we have an acceleration in the x to the right, which means your acceleration in the y is 0. So in order to have an acceleration, that simply means you have to have an unbalanced force over here. They can't add up to be 0. So on this, you simply have to have force of the 4 to be much bigger than F3, right? So that when you type it into this equation, F4 minus F3, you will have a value here. If they're equal to each other, that would be 0, making the acceleration of 0. So what we can say here is that F4 must be greater than F3. If F3 was greater, you would have a negative net force, giving you an acceleration to the left. In the vertical, right, if we want AY to be 0, we would have F1 minus F2 equals MAY. The only way y is 0 is if these two are equal to each other. So in this case, we would say F1 equals F2. And if that's the case, then AY would be 0, right? Because these two would cancel out. They're balanced. So remember when we did all that way at the beginning. So for that answer, that would be your best choice. F4 greater than F3, F1 equal to F2 for the case where you have acceleration to the right and there is no y acceleration. My second question on that asks, then what would happen if the object is accelerating upward and to the right at the same time? So if I have an upward acceleration and a rightward acceleration, that simply means we again have an AX. Let me just be consistent here in my colors. Right? We'll redraw our forces. So we have F1, F2, F4, and F3. So we want an acceleration to the right, and we want an acceleration that is up. So in the end, that's going to mean that the object is accelerating along this line, right? So it's going to be moving like that because there's going to be a net force, net acceleration to the right and up at the same time, and therefore it'll move at an angle. So again, looking at your equations, right? That means that F4 minus F3 must end up in the positive direction, making an acceleration to the right, which again means F4 is greater than F3. So what that means is we want that to be positive, right? We want this one to be positive. So in the y, that would mean you have F1 minus F2 equals MAY. If you want AY to have a net positive acceleration, you need FY1 to be greater than F2. So my answer for that one would be F4 is greater than F3 and F1 is greater than F2. All right, so that got us back to the basics and leads us into what happens when we are at angles, right? So if you have a net force in the X and the Y, you have acceleration in both of those directions, giving you an acceleration along that line, right? But sometimes when we look at problems like these two, which seem to give most of you a lot of trouble, these two problems here with the elevator, those are just straight up and down, right? So in those pictures, you can check your work with my written solutions that I've scanned and sent to you. So I'd like to concentrate on numbers 1 and 2. Let's take a look at those two problems. Okay, looking at number 1, similar pictures. You just are changing what you're being asked for, really. All right, so if we draw the free body diagram for number 1. So again, this is the UT Quest assignment. Newton's Law 2. And this would be on my sheet, problem number 1. I think your order of problems are the same way, just the numbers would be different. So again, your values are going to be different. So I'm not even going to put in any values until I get to the end. So we're going to go show you the process, right? We draw a basic picture. We have a block that's on the floor that's being pushed by two forces, one force going to the right. For me, it has a magnitude of 29 newtons, but I'm simply going to call that force 1. We have another force going down and to the right, or down and to the left, acting on it like this. That makes an angle of 60 degrees with the horizontal. I'm simply going to call that F2. We do have some other forces here. Of course, there's going to be weight. So we go through our list. Would there be weight? Yes. Would there be a normal force? Yes. And the normal force acts to push the two surfaces together and acts perpendicular to the two surfaces. Is there sliding friction? And the answer is no. If I go back to the question, it says frictionless surface. So there is no friction. Okay. So actually, already my numbers are different. So every time you pull up the questions, I guess I'm getting different numbers myself. So I'm going to put the numbers that I had on my problem. But again, we're just going to set up how this problem would look, right? So for me, I was given in my original problem that this F2 was equal to 87 newtons at an angle of 60 degrees. So that's the scenario. So that's your first picture. Then after that, you clean it up a little bit, right? And we recognize, oh, this force is at an angle. So off to the side, I'm going to kind of draw that force. Remember, whenever you have a force at an angle, you want to break it up into its components. So what I need to recognize is I want my X and Y to be like my original X and Y. This is a case where everything else is in the vertical and horizontal. This force 2 is the only one that's not. So I'm going to keep my X and Y components like that. And I'm going to say I have to go from here to here, but I'm only allowed to walk in the X and Y directions. That means I would go down first and then across like that. This would be F2Y. This is going to be F2X. This angle is 60 degrees here. I definitely could have done it going across and then down. That's perfectly fine. This would be my 60 degrees in that case. Either scenario is fine. It just matters on what you label as cosine and sine and what angles you might have, right? So keeping it like that, I recognize that, okay, my F2y is on the opposite side of the sine of 60. So I will write sine of 60 degrees is equal to F2y divided by F2. So F2 sine 60 degrees is equal to F2y. That simply comes from SOHCAHTOA, right? F2x is on the adjacent side of that. The hypotenuse is F2. So the adjacent side goes with the cosine of the angle is equal to adjacent F2x divided by the hypotenuse. So F2 times the cosine of 60 degrees is equal to F2x. So I'm going to redraw my picture with the components instead of the one at an angle. So when I redraw my picture, I have F normal, I have weight acting down. Now I have F2y also acting down, and I have F2x going to the left, and F1 going to the right. So again, same process. You draw a picture, you clean up what's not in your X and Y, do SOHCAHTOA to find the components, redraw your picture with everything in what you want to be the X and Y directions. Then you write your formulas. So my formulas for this problem would be summation of forces in the X equals MAX, anything to the right positive, to the left negative. So I would have F1 minus F2x equals MAX. In the y direction, summation of forces in the y equals MAY. So in my y, I'd have F normal minus F2y minus W equals MAY. So notice what I'm doing. I have not put in any numbers yet. I'm setting up equations for me to be able to solve for things. Keeping in mind, you always have the equations that the weight of something is mass times acceleration due to gravity, and force of friction is equal to mu times the normal force. So those equations should always be in the back of your head as well. So that's the long part of the problem. Do that nice and neat, keep it organized. Now you go back and you say, what do I know and what do I want to know? So this truly is step one that takes a lot of work. After that, you now then go through our problem solving steps, right? List what you know, what you want to know, which one of these many equations you now have set up for this particular problem is going to help you to make sense of this. So going back and reading the problem, it was a frictionless surface. The mass of my block is 3.2 kilograms. Okay, so I have 3.7, sorry. So if I list what I know, I would say, okay, mass, I want to keep all this work here. Mass equals 3.7 kilograms is something that I know. I know F1 is 29 newtons. I know F2 is 87 newtons. I know it's not bouncing up and down, so AY is 0, and I'm looking for AX. What is my acceleration in the X? So the only equation that has AX is this equation right here. So I'm going to write that equation. It would be F1 minus F2x equals MAX. So I go through my list. Do I know F1? Yes. Do I know F2x? Well, up here I have an equation for F2x. So I would say, okay, that's F1 minus F2 go up here, right? Cosine 60 degrees equals MAX. I know F1. Do I know F2? Yes. Cosine 60. Do I know my mass? Yes. All right. Solve for AX. So divide by M. Mass cancels over here. So your equation becomes F1 minus F2 cosine 60 degrees equals AX divided by mass. So plugging these in, 29 newtons minus 87 newtons times the cosine 60 degrees all over the mass of 3.7 kilograms gives you AX. So everybody should have this equation. Your work should look the same. The difference in each one of your problems is the numbers that you're going to plug in there. That's why it's beneficial to do all that work. Don't worry about plugging in numbers until the end. So I get my acceleration in the X to be a negative 3.92 meters per second squared equals AX. So the question becomes, what does that negative mean? And this is where a lot of you are having trouble plugging that in, because it asks for, if we go back to the question, what is the magnitude of F? So if it's only asking for magnitude, it's not asking for direction. So what this is telling me is this force F2x is more than F21, just like we described up here. So the acceleration is going to be to the left, which makes it negative. But if I only want magnitude, I only want to know how strong of an acceleration it is. So my answer would be 3.2 meters per second squared. That's what I would plug in for my UT Quest. All right, trying to make that all a little bit smaller so you can see that whole work. All right, I don't know about you, but I think that looks pretty good. We'll go back over here now. What happens next? Now, given these forces, I want to know the acceleration. What is the magnitude of the force necessary to cause a particular acceleration? So again, I'm going to go back, draw my picture, right? So in this case, we've taken out the other horizontal force, the F1. We only have that, and we want to know what is the acceleration. So I'm going to expand this again. And now we're going to look at number 2 on the UT Quest. So for my numbers, we have a block. Go through the list of forces, right? Would there be weight? Yes. Would there be a normal force? Yes. And then there's this applied force that's acting again down at an angle. And for my number, that angle is 32 degrees. I'm going to call that, you can call it force applied. I'm going to call it force 1, just to kind of be consistent with what I did up at the top. And the only reason I used 1 and 2 at the top is because they were 2 different applied forces. So again, this force is at an angle, so off to the side. I'm going to break it up into its components. I'm going to agree that I want my X to be this way and my Y to be this way, right? So I have to be consistent with that. That's my X and that's my Y. So if you notice, I like to draw that coordinate system right at the tail of the vector to give me an idea of how do I have to move? What do the components, what are they going to look like? So if I go from here to here, I want to move only in the X and Y direction. So again, I'm going to go down and across like that. This angle here is 32 degrees. So if that's F1, this is going to be F1Y, and this is going to be F2Y. I'm sorry, F2X. All right. So with that being 32 degrees, using SOHCAHTOA, the sine of 32 degrees is equal to the opposite, f1y divided by f1. So f1 times the sine of 32 is equal to f1y. The cosine 32 degrees is equal to the adjacent f2x divided by f2. So f2x, oops, I'm sorry, f2 times the cosine 32 is equal to f2x. So I get that by multiplying both sides by f2, of course, right? It cancels over here, it gets my f2x by itself. Again, I'm going to clean up my picture, right? So if I clean up my picture, just draw a dot representing the object. We have a normal force. We have weight. We have f2x. And we have f2y. Okay. So in this case, we write out our equations. So again, it's the whole process. I don't even care what it's asking for. I don't even care what I know yet, right? I clean up my picture. I write out my equations, to the right positive, to the left negative. None of this is different than what we've been doing all month, really, for weeks. We just keep adding to the problems, up positive, down negative. So in my x direction, all I have is f2x. It's actually going in the negative direction, equals max. In my y, if I take up to be positive, I'd have f normal minus f2y minus w equals may. So those are my equations, along with W equals mg and force of friction equals mu times the normal force. So that's what I should be thinking about as I now decide, what do I know? What do I want to know? So this is a long process, but very, very important. So if I go back and say, okay, what do I know? I was told that the mass of the object, for my numbers, your numbers would be different. So we were simply asked to find what is the force. Why did I call that force 2? I apologize. Throwing in numbers of 2. These all should be ones. Ones, ones, ones. Sorry about that. Thinking of the previous problem. So this is all f1x, f1y, or maybe you called it f applied. Right? These are all 1x, right? f1x, f1, 1, so on. Okay, just to be consistent with my picture. That's the only force I have. So what I am given, I'm looking for that force. What is force 1 is the question. How much is the force? Not the x or y component. I want to know the actual force. If the mass is 4.77658 kilograms, okay, what else do we know? We know acceleration in the x is equal to 3.4 meters per second squared. Again, more than likely your numbers here are something different. I do know acceleration in the y to be 0. It's not moving up and down. And that's it. So the only place I really have f1, I have f1x here, f1y here. Given that I know this, I think I can just solve it with this simple equation right here. So I have negative f1x equals max. Now keep in mind, these are all forces, right? Vector quantities, including the acceleration. So I do need to write, if I'm going to take to the left negative and to the right positive, this acceleration is also a negative value. So my f1x, I know to be, if I go up here, f1f, x is f1, that should have a 1 underneath it, cosine 32 degrees divided by my mass is going to be my, what? That's not what I want. I don't need to divide by mass because I'm actually, in this case, solving for F1. So I'm going to divide both sides by the cosine of 32 degrees. Because what I know is mass, acceleration, and I know that. So F1 is equal to max divided by cosine 32 degrees. So plugging in my numbers, F1 equals 4.77658 kilograms times negative 3.4 meters per second squared divided by cosine 32 degrees. Right? And I lost my negative up here, so that should be negative. So you end up with negative F1 equals negative 19.15 newtons. And then of course the negatives cancel, you end up with a positive number. And that simply means, it doesn't mean the F1 is necessarily positive, it just means you chose the correct direction in your picture in this case. So even though it is moving to the left, right, it is in the negative direction, which was my correct assumption here. If I had gotten a negative answer, then my assumption of my direction of my force is not correct. All right, so that's problem number 2. Takes a while. Organize your work. It's important to keep things all organized to make sure that you are not missing numbers, missing negatives. So don't make it too difficult. But notice, I never really needed that. I never really needed this equation. I definitely didn't need these. So it may seem like a long process, and it is. But if you do this, every single problem will flow and you'll be able to understand. But if you just right away, try to solve for something, it might work for one problem, but give you trouble in another. All right, so good luck. You can check the written solutions for the rest of the problems on this UT Quest. So I have posted all written solutions to those as well. So take a look at that work.